All right. Happy Tuesday. Let's get this. Still have my puzzle up from yesterday. Haven't even set up my project. Smab is saying that this well, Smab says good luck. That is foreboding. That almost feels like a warning. And Gupta took 3 hours, so we'll have to be careful. We'll have to be careful. Let's make a day 13. Day 13. Yesterday I had the dumbest bug I had. Oh, the worst bug, and I should have taken a break sooner. I was streaming, so I didn't take a break. If I had just taken a break, as soon as I took a break, I realized what the problem was. Took me a second to figure it out once I took a break. I just had during breadth first search, I wasn't marking the nodes visited at the correct spot, and so the solution I had actually worked. It was just checking. It was horrible. It was just very, very inefficient and slow. That's why it worked for the small example. Oh man. All right. Let's get that chat over here so people who are watching this in the future know what I'm talking to, who I'm talking to, what I'm talking about. Mab has set a solution from yesterday. We'll look at that real quick. Let me get my project set up first. .NET new solution. .NET new XUnit test. Oops, that's not what I wanted. Add in that solution there. But I'll have to be fastidious. Fastidious. Keith, happy Tuesday, my friend. Happy Tuesday. Where am I here? .NET SLN add solution test. Is it Wednesday? Oh, Wednesday where you are. It's Wednesday where you are. That's what you mean. I forget what day it is all the time. My students find it hilarious. I forget how old I am sometimes. Once I hit age 25, I sort of stopped remembering. I've got all kinds of extraneous stuff up on my screen. New Zealand, the world leaders of time and other things. That's good. That's good. All right. I wasn't sure if I was going to be able to break down yesterday's problem into a beginner's guide, but I felt like I managed to do it in a pretty good way. But it took me forever to reduce it down into something that I felt was easily testable. That was the hard part. All right, let's check it out. Yeah, it took me, so most of the videos have taken me about 2 hours to do that one. That one I had so much to do yesterday, and yesterday's video took me, I think, 4 or 5 hours to rework, record, and then put it all together. It was long. And that's not my normal breadth first search solution. Usually when we do breadth first search in my algorithms, or what I would call my intermediate class, sort of the second term class after you've learned classes and whatnot, we do a graph-based search. So I couldn't really reuse what I've done there. So I had to think, okay, how do we do it for this specific problem? All right, we're looking at, this is hill climbing. Okay, for a second I thought we were looking at today's problem. Hill climbing. We've got an init. which loads in the elevation map. And thank you for watching it. Let me know what you thought. I was really happy with how it turned out. Elevation map, select mini, inputs a row to 2D array, go over the array. Okay, so we do a conversion. It's called a Remarkable 2. So the e-ink, I got grandfathered in. I love this thing. This is the device I have, the Remarkable 2. This is not, I'm going to recommend you don't get it. Okay. I'm going to recommend you don't get it now. So I got it before they switched to a subscription model. All right. So I got my version 2 years ago. It was, I think, like $500 or $600, but they've lowered the price, switched to a subscription model. I got grandfathered in, so I don't have to pay that subscription. So the downside is if you want it to be like connected to the cloud, you have to pay for it. One thing that's really cool is that it's just running on a version of, I think, BSD Linux. So you can write little Python scripts to run on it. It's a very slow processor, but people have done some really cool stuff with it. I love it. It's great. If you want to pay a subscription, you can get it. It's not a tablet though. It has very little purpose. Oh, not very little purpose. It's only a notebook. That's essentially it. Can't browse the internet. Can't do much of anything else. I love it though. Sketching on it. The coolest thing about it is I don't know if you like drawing. It feels like you're writing on paper. That's the coolest part about it. Is it feels like you're writing on paper. Start point is at S, endpoint's at E. Cost equals zero. Calculate cost endpoint. Okay, so I'm assuming calculate cost here. Let's go look at calculate cost. Is this sort of where we do our recursive search? Get adjacent cell point to list for each calculate. Yeah, so then you go through and you calculate the score for previous. So we're doing essentially a recursive solution here, which is nice. So it ends up being a depth first search. Is that true? Calculate adjacents if the cost. Let me do that. Yeah, so you just calculate the cost of it and then you pull that value out. Is that what's going on here? And this is our rule for connections. Yeah, I hemmed and hawed over whether or not I wanted to create a graph-based solution for my video, where I was like, okay, well, we're gonna think of this as sort of locations with paths that go out of locations, and you build up a whole graph, but then that was just going to be too complex. So essentially the solution I came through is, well, you calculate the whole thing, but there's the escape hatch of, well, once you've calculated that position, you know you're done. Okay, I really like how short this is, how concise it is. Nice look. This looks nice. And of course, thank you for sharing. Thank you for sharing, Smith. You learn. So one thing that young programmers don't do enough is read other people's code. Oh, this is definitely using some. This doesn't look too bad though, as far as extra stuff Snap's written. I like some of these things. 2D array, and then you also have two or as int, and You have some great helper methods that I wish I had. Day 12. One of the memes on the subreddit was so good. I don't want to go there yet. I don't want to get any spoilers, but there was a meme yesterday that said, you know, me as a software engineer pretending I don't want to be on the leaderboard, but I really want to. And then it had a list of all the people you're competing against. I don't know if anyone saw that one. Here we go. Day 12. Me too, Keith. I am trying to keep mine self-contained, mostly so when if I can direct a student to watch a video and there won't be anything particularly tricky, right? I want it to be sort of self-contained as well. Mine is called position. So you have a waypoint. Ours looks almost identical. In my first solution, I had this, where I had the pointer back to the parent. In the solution I did in my video, I ended up getting rid of this and just having a waypoint. For equality checks, I wanted waypoints to not have a parent. And I ended up not using graph-like structures. The solution doesn't require you to be able to compute the actual path, just to know how far away it is. This is nice. Excuse me on clearing my throat there. And then we solve. Read it in. Turn it into a 2D list of location. What's location? Oh, and then you did a visualization. I was going, what the heck? What's location? Oh, location, care height. Okay. Oh, and marking whether or not it's visited. All right. To terrain, we get that array back. Traversable. So we're going to determine whether or not it's traversable between these 2 points. We pass in a predicate that takes in 2 points. You didn't convert it to integers initially. You kept them as characters and you're doing a compare with that. That's smart. And then here's that check here. You convert S to A, E to Z. This was this is one reason why I decided not to do character compares, because we had these special characters in there. Although you could just do a replace like you've done here. We make sure it's in bounds and that it's not visited. So if it's outside of bounds or we visited, we cannot traverse it. No marker. Navigate, waypoint, terrain, begin, end. Okay, and so then this is going to navigate to a position. So this is the actual search here. Initialize a breadth first search queue. Well, it's not empty. Keep chunking away at it. DQ it. If we find the end, we're done. Otherwise, mark all of or enqueue the nodes, the neighbors, set the parent so we can backtrack. Mark it as visited and continue. What is this I++ doing? Is this just left over? Oh, gotcha. Yeah, so the solution I ended up doing in my video yesterday, I decided if someone really wanted to do a backtrack, they could probably recognize, oh, hey, I just need a second array here with the positions to the previous. So that would be the trick there. So, just the position from the previous will get me back. Gotcha. This is just some leftover thing. All right. We calculate our path. we get the length of it. And this is our rule on part 1. This is our rule on part 2. As soon as we see any AoE end, nice. Really good solution. I love your visualization output. Now you got to turn it into a GIF format, animate it. All right. The other cool part, I don't know if you guys saw my here, let's get that up here. I haven't even started the puzzle yet. I'm not gonna have enough time, all right. Geez, this repository is a mess. Nice piece about the version I implemented in my video is it would be really easy to visualize because it has this method that it does one exploration step at a time. So if you wanted to do a visualization, you just add a little delay between each time you call explore. So it sort of does one step at a time, put a little delay in there, and then you could say, oh, well, I have a little thing that knows how to render an explorer. 13 seemed to slow many people down. All right, well, now I'm nervous. Let's read about this distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Of course we're going to get a distress signal. The elves are incompetent. They can't do anything without us. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, your puzzle input, to decode the message. They should have been using TCP. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. For example, so pairs of packets are separated by a blank line. So we're going to have, I'm assuming this is a pair. This is a pair. Ooh, this input looks like it's gonna, okay. Well, let's keep reading. We have lists of ints and non-homogeneous lists. What's wrong with people? Non-homogeneous lists. Packet data consists of lists and integers. Yeah, so each list starts with a bracket, ends with a bracket, and contains 0 or more comma-separated values. Can either have lists or other lists. Each packet is always a list and appears on its own line. This is where union types would be really nice. Does C# have union types? I don't think it does. When comparing two values, the first value is called left and the second value is called right. Okay, left and right. If both values, when comparing two values, the first value is called left and the second value is called right. If both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is lower than the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. Okay. So the first value, the packet that's coming first should be considered less than the packet that's coming second. That makes sense. And we compare down the line. So this packet would be in order because 3 becomes before 5. And then we can sort of, if we're doing just like a compare, we can sort of stop at this point, I'm pretty sure, because we already know it's less than. Anything that comes after, it doesn't matter. You can do them with records. That's essentially, well, we'll see. We'll see what it looks like when I get there. Well, because I want a record. So here, I don't know if I can do it with record types. I don't think I can do like a true union with record types. I'll have to do like subclasses, right? If both values are lists, compare the first value of each list, then the second value. Compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. So in the second value, if the left list, compare the first value of each list, then the second value, and so on. So we compare the values of the list, checking if they're, if the left list runs out of items first, the inputs are in the right order. So if the left list is shorter than the right list, they're in the right order. If the right list runs out of items first, the inputs are not in the right order. Ugh, this is just a weird sorting problem, isn't it? If the lists are the same length and no, maybe not weird. If exactly one value is an integer, convert the integer to a list which contains the integer as its only value, then retry the comparison. For example, all right, so if you have a raw integer compared to a list, convert the integer to a list. All right, I think I kind of have it. It is too early for my brain. Over on Google, we got Thens. It's good to see you. Happy Tuesday, my friend. We're letting our brain melt a little bit here. Okay. What do we got over here? I was talking about union types. You can do them. They had a Q&A last week where they were discussed. They want them for things like the minimal APIs. Yeah, there are. It's one of the things I actually love about the data types in, say, Haskell. The union types are just nice. And then type classes for essentially saying this data can be operated on in a specific way is nice. It's a really nice way to think about data. All right, so I'm gonna have to define. We have lists of non-homogeneous. So a list of. So a packet is a list containing packet items, and a packet item can be an integer or a packet list. That's sort of what it is. Kesavan on YouTube. I never get anybody watching on YouTube, but I am today. So good morning, people on YouTube. Kesavan, hi, nice to see you here. Happy Tuesday. Okay, let's make sure my logic makes sense here. So we have the first pair coming in 1 1 3. So the ones compare. The ones compare. The 3 versus 5. Left is smaller, so we're good. It's in the correct order. So, and then we need to basically do a compare where we determine which if we're in order or out of order, right? So then we have this list, this packet that has 2 more packets in it. We compared the lists, the first list with the second list. They're equal, so we keep going. We compared this with that. We're gonna have to promote this to a list. Geez, I'm not looking forward to this. 2, 3, 4 versus 4. 2 is smaller, so they're in the correct order. Parser's gonna be. This is where a recursive, what would be a parser combinator would be great here too. I want a parser combinator. So I'm gonna have to write a parser for this, I think. That is not gonna be the most fun thing in the world. Compare this list 9. The first element is a 9, and the first element is this, so 9. So there's like a recursive. This puzzle's a little tricky because it's like a recursive compare. We're comparing structural equality, and then 9 is not there, so it's not in the right order. Oh, all right. I think I get it. 4, 4 compares 4, 4, and then the left ran out, so it's in the right order. The right ran out, so it's not in the right order. Part 2 is gonna be I actually have to sort this thing, don't I? But there's gonna be some kind of weird twist where you have to sort it, and then you have to like using demon horde sort or something weird. Okay. I think I get it. All right, so what are the indices of pairs that are already in the right order? The first pair has index 1, first pair has index 1. Why? Why? Stop it. This is not MATLAB. That's what I need to just start doing all of my solutions in MATLAB or Scratch so that my indices are I don't have to worry about indice errors. Okay. Then we sum these indices. Okay. All right. What's my input look like? Oh God. Okay. All right. Let's define a data type here. Keith is convinced we can do record or union types. Let's look at it here. Because Eric is evil, yeah. That's record current item string value, record payment decimal value. Public record empty cart. Yeah, this is so this isn't union types, this is inheritance. So you can sort of emulate union types and then use pattern matching to kind of do it. So you can it's not a real union type though. You can emulate it using inheritance. Oh man. Have all the problems been I don't think, and the thing is, not all the problems have been one-based indexing. Okay, let's define a type here. So we have packet. I'm gonna call it packet list because it's gonna make my brain hurt if I don't have the word list in there. So we have a public record packet list, and hang on, we'll call it a packet. And a packet contains a public record. All right, I gotta make my brain work here. Or public record packet int val. Okay, so a packet list contains a list of right. So this is going to extend packet. This extends packet. And this is going to have a list of packet. packets. All right, I think this is my type. Yeah, fair. Because we have pattern matching with the switch statements, it ends up working out nicely for us. Okay. So then we have to implement, so like a compare on them. So in our record, here, we need to have, all right, this is going to be abstract. Public, abstract, compare. Wow, we're getting a lot of people over on YouTube today for some reason. Not a whole lot of chatter there, but Tamil, what's up? Happy Tuesday. At least Tuesday where I am. Compare, and this is going to take a packet other and define how it works. Public, oh, this should return an int. Public int public int compare packet other one. What am I doing here? Implement. Wants to add in a bunch of extra stuff here. That's okay. Okay. I'm gonna have to do this. Let's add in a toString as well to make this a little bit nicer. Public override string toString. This is just gonna return val. It's gonna make me toString. And well, packet is abstract, so the idea of a packet, maybe I don't want an abstract. Now you got me all worried. My idea is a packet is either a packet list. We got another person over on YouTube. Martin, happy Tuesday, my friend. We'll keep going here. Keith has me nervous. Well, you know, the way you compare is slightly different between because of maybe. All right, let's keep going here. Vanavan also on YouTube. Happy Tuesday. Something's happening over on YouTube. I'm gonna keep it abstract because the way I compare them, I think, is slightly different. I don't know. Well, I may find that the code is actually the same up there, because I still need to. So in this case, I know that the left side is an int, and this one, I know the left side happens to be a list. And if it's not, then I promote the other one to it, and then I check it again recursively. Yeah, so let's keep going here. Smab. Well, welcome to YouTube. I don't know, my bandwidth just might not be able to actually handle it. I normally just stream to both. There's usually no traffic on YouTube, but I like that it saves it. Oh, it is looking like my internet is struggling here. Probably because I actually am having traffic. Oh, well, hopefully we can keep going here. I'm sorry the stream is not It is dying on us. I didn't notice it. I've never seen that happen. I wonder what's going on this morning with the internet connection. All right, so when we compare here, we want to return other switch if the other is a packet int x. Let's see, can I do this? The other is a packet int. How do I do the match here? Packet int. The switch expression does not handle all. So if it's a packet int, I return this dot compare against a packet list with a new list containing other dot val. Containing other. Is that right? How to throw exception in C# explained. All right. New list of packet other. Okay. So if it's an int, if I have a list and I'm comparing that list against a packet, I need to promote the packet to a packet list and then do the compare. Otherwise, we need to do something else. Otherwise, exception for now, do something else. We'll look that up in a second, but this is the part that I remembered. Similar, if we have an int on the left side, we have an int on the left side and the thing on the right side. So if it's just a packet int on the left side, then we return val minus other dot val. Other packet is not contain a val, but I know other's a packet int here, so I cast it to a packet int. Ooh, interesting. This is interesting here. I'm not sure how to do the pattern match in this way. If other is a packet int, how do I have a reference to it? If I'd label it, can I label it this way? O dot val. Okay, you can label them this way. All right, I haven't done this type of pattern matching before in C#, so this is new to me. So we turn val minus O dot val. Otherwise, we need to promote ourselves to a list and do the compare, because otherwise we have a packet list like this. If we're a packet list, we are going to promote ourselves. So new packet list. And for ease, I'm going to write a method here. Public packet list of packet Do I need to do a packet? No, it's just packet list. We're gonna call this promote. And this is gonna promote ourselves. Just gonna do this. So it's gonna return a new packet list with ourself inside it. New list packet. This. Okay. So we can promote ourselves. Otherwise, we do this dot compare I dot promote. Like that. We have a packet list on the side. We do this dot promote dot compare other. All right, so that's the whole case for when we're down at the integer level. Now we need to do the actual list compare. So if we have we're just a packet int. Let's think here. If we are just a packet int. Christoph. So we have a person in the Twitch stream here. Christoph, thank you for following. I hope you're enjoying the stream. If you have any questions, feel free to let me know. It's packing it, we just subtract it. Otherwise, we go in and continue our compare here. Okay. Martin over on YouTube, thank you. Thank you. I'm doing my best. I'm hanging in there. Sweating my way through this part 1. Okay. What am I doing? And otherwise we're a list and we need to examine the list. Okay. So I'm just gonna write a little helper here. I know that they're both lists. All right, so packet list L. And we're gonna do dot compare. I'm gonna do a static helper, I think. Compare lists this and L. And then I have to write that in here. Public static int compare lists. Because this one I need to like sort of go down one by one looking for it. Maybe I should not use the built-in list type. Instead, I could have my own list type that sort of has a head and then a tail, which is a packet list. I think that's the easier way to do this, actually. Yeah. So I have a packet head, packet tail. That's how I'm gonna do this. Tamil wants me to solve HackerRank challenges in live. I'm working on the advent of code right now. I've done HackerRank stuff in the past. All right, so promoting this to a packet list. Now I have a null here. And I just pass this in like that. So promote just becomes a list with one item. Compare should hopefully be a little bit easier now. So if I have, I'm gonna compare. Let's think this through. This is a interesting puzzle here. So now I need to compare the head. I have packet list with a head and a tail. and this has a head and a tail. I'm still gonna write a helper method here because I think it's just gonna be easier, and I might inline it here in a second. Public static int compare lists packet lists ls and packet. These names are Haskell names. They're terrible. ls and js, and we're gonna say if ls dot compare js is first. Oh, okay. All right. So if we can also be empty. I'm missing an empty list here, or a way to represent an empty list. All right, so we can have a null head here. All right, so the first, all right, so now we have the case where the first list is empty. All right, so if ls.head is null, return -1. We're in the right order. If js.head is null, return 1. We are, so this would be ls is empty. I guess I could do an empty list type. I don't like that though. Oh, you know what? That'll make it so I don't have to deal with null types. Yeah. We'll keep packets here. Public record empty packet, empty packet extends a packet, and public override int compare packet other. So an empty packet compared to anything, it comes first, right? Return -1. The empty packet always comes before the other one. I guess if you're comparing against another empty packet, you might say, well, 0. I'm just gonna say that empty packet, the order is always -1. Empty packet always comes first. Okay, so now if we're comparing a list empty packet, so if we're comparing against an empty packet, this list is not empty, so we're going to return 1, that this thing should come after throw new exception unknown packet encountered other. Okay. Okay, so now I have the case where my empty packets always come first. If I'm comparing against an empty packet here, for int, if I am comparing against an empty packet, I think I can bypass it. I know I'm gonna promote to a list, and then the list will be empty, so I can also return 1 here. Okay. Let's keep going. So now all that's left is to compare this. So I know that neither of my lists are empty. They both have a head. I know the head's not empty. Because I'm a packet list. Yeah. So it has to be. Oof. Okay, so return. We need to compare the heads. Oh, we do need to know if they're equal, because then we need to keep going if they're equal. Okay. So here we can't always do -1. Return other switch. If it's an empty packet, return 0. They're equivalent. Otherwise, return -1. This one comes before. Empty packet. Yeah, empty packets will never be greater than anything, I believe. We're comparing a list against an empty packet, we're going to be bigger than it. And then compare list here. We'll throw an exception here. Let's keep going. Compare lists. We compare the heads. So we're going to say int head compare equals ls.head.compare with js.head. We compare the front of both lists. If head compare is 0 or is -1, if it's 0, we need to continue. Otherwise, return head compare. All right, if the head compare was not 0, if it equals 0, we need to move to the tail. Then we're going to do return ls.tail.compare with js.tail. Okay. All right. I think I have it here. We were going to write a toString. That's right. We're going to write a toString. I did a lot of logic in here. No unit test just yet. But I logicked my way through it. The list here, if we're a list type, we are going to return ourselves in angle brackets plus a string dot join on our well, we're gonna do our, hang on, I don't have like a list here anymore, so it's actually gonna be ls dot or head dot toString. And then if plus, it's not quite our tail. Isn't our tail? Because if we're a packet list, we sort of need to just iterate down. There's some cases here. All right. Run another helper private. All right, so if there's sort of a case here, there's a case here. Return head. We know our head isn't empty, but our tail could be empty. For a packet list, our tail could be empty. So we're gonna do return tail switch. And if our tail is empty, if our tail is empty, if it's an empty packet, then we don't put anything. Otherwise, we are going to recursively call the toString tail.toString. I could probably implement an yeah. Thank you, Gupta. I'm probably all right. So public override string toString. This is gonna return. The issue is though, if I have just an empty list, it returns empty. But if I'm a list, I don't actually. When you have a list with the empty list looks like this, but a packet list, if I have a head and a tail, this doesn't feel like it's gonna this doesn't feel like it's gonna work right here. So if it's like a list here, it's sort of if the tail is a list, I need to. That means did I build this up wrong? This might be an indicator that I've built it wrong here. Let's see if I can build up some of these example lists with the data structure I have here. All right. Let me go ahead and do it in my tests. We'll call this packet test. Packet test. All right. I need a reload here. One of the downsides of using VS Code is that sometimes it cannot figure out how to communicate properly with. Wait, what? What's going on with my test here? Packet tests. This is weird. All right. Are these real errors? .NET build. There's a circular dependency. Oh. I know what happened. When I was setting this up, I accidentally added this to itself. There we go. It just shouldn't let you do that. It should be able to detect that, I think. I would think. Maybe not. Okay. We are going to test first pair test. And we're going to try and build up. Well, these two are easy. I'll build that later. Do another one. We want to have lists of lists. We're going to do this one. second pair test. Just for sanity. Can I build this? I think I can. Here we go. We have packet P0 equals new packet list. All right. And its head is going to be a new packet list with a new packet int1. And empty packet. New empty packet. And then the tail will be a new packet list, which is new packet int2, comma. We're gonna get real nested here, like writing scheme all over again. New packet list, packet int3, comma, new packet int4. No, this is the functional way to do it. This is exactly how I would do it. So the issue is I'm thinking of it in Haskell. In Haskell, this is how list is defined in Haskell. Oh, the whole reason I did it this way is to make the parsing easy. This is gonna make the parsing easy. I think. Although maybe I should have stuck with. All right, and then this will be new. All right, maybe I should do something different. You're probably right. This is so I can't. This would be my. Is it to make the parsing easier? Or is it to make my Haskell brain happy? Oh boy. All right, so there's packet 0. Oh god. Because the idea is a list has basically you have like a head, which is an item followed by the rest of your list. So it's gonna end up being like a recursive parser. I probably should come up with a better solution simply because my students, I'll never be able to get my students to do this. All right, so the first element. Sorry, this is too funny to me. New packet int 1, new empty packet, followed by a new packet int 4. Okay, so I can represent this. I just need to figure out how to do a why can't I figure out how to do this here? It's oh, that's the whole reason I had this. Okay, all right. The whole reason I have this, I'm gonna have a helper here. So private static string without parens. If they were, look, if if we were writing Scheme, this would be beautiful. If we were writing Scheme, this would be fabulous. This would be fabulous. If we were writing Haskell, if we were in F sharp, may not be as fabulous. I'm doing this the you know, the hard way. I'm doing it the true programmer way. You don't think this is beautiful, Smap? Look at that. Look at those indentations. Don't you want to have all the parentheses everywhere? Oh man. And then this just becomes, that's a big if. This becomes without parens. All right. And now we build this up. Now we build this up. So we're gonna return, we have a case here. So we're gonna do return. This is the recursive, horrible recursiveness. If our tail switch is empty, if it's an empty packet, so if our tail is empty, we just return head.toString. If it's not empty, if it's not empty, we return head.toString plus a comma plus tail.toString. There we go. All right, let's try toStringing this. Assert equals this string versus p0.toString. All right, let's do some madness. All right, come on, test. Make me happy. Did I put spaces? No, no spaces. All right, let's. Failure. All right, what did I actually get back though? I have a space. All right, so I have a space. They want it to have no spaces. Thank you, Gupta. Still a failure. Oh no. Okay, all right, so I have one thing here where I'm gonna say if I am a, if, oh boy. Because my tail, my tail, this should be without parens. Oh, but it doesn't know if I'm a list. Interesting. Interesting. My brain's, okay, so if, I can do this. I can make this work. I can make it work. You just gotta believe in me. Do you believe in me? I know, I know. All right, so what is the issue here? If my tail is a list, yeah, so it's a packet list, ls, if it's a packet list and the head, I need to do another, I've done something terrible here. ls switch Oh my goodness. The pattern matching is not powerful enough here. Not powerful enough here. So I need to match on the head of my tail. All right, we'll call this tail. If the head of my tail is a list, hang on. Yeah. So if the head of my tail happens to be a packet int, then Goop is saying, don't you need head without head dot without? Yeah, it's like tail dot head. Is that probably? I'm getting there. I'm weaseling my way through this. For 52. Well, if it's an empty packet, oh, thank you. I'm doing this the nightmare fuel way. Oh no, so if my so here's the thing, if my tail is empty, I'm done. I just get my head out. I pull my head out, and this will be if I happen to be a list inside of a list, it's gonna go inside that. If my tail, here's the thing, my tail will never be an int. I actually think I should have defined. Oh, I should have defined this as a generic type, and then you actually have values down here. This, I have my type is defined incorrectly. That's what's happening. My type is actually defined incorrectly. Okay, my type is wrong. This has shown me that my type's wrong. I actually don't have a packet int. Yeah, I don't have a packet int. I have packet, I have empty packet, and then I have an int head, and then a packet tail. So this actually becomes that it's a packet list. I should have just used the built-in list. That was what I was doing initially, and then I thought I was being clever here. Yeah, I thought I was being clever. Oh, the problem is my packet. Hang on. I really want, when I have a packet list, my int can be. Well, when I have a list, yeah, well, that's why I was saying, like, it's non-homogeneous list. That's why this is becoming tricky, is that it's not that the problem is my lists are non-homogeneous, and so that's where the insanity is happening, and that's why I'm having trouble here deciphering if my tail is empty. All right, I almost blew that up there. So the problem I have, ooh, you're right. This should be the type. This is where, like, union types. This is where I'm missing a true union type. I think my tail can either be a packet list or empty. So packet list. All right, so I would do this public record. All right, let's rename this. Non-empty packet list. And then a packet list, public record packet list, extends packet. And we'll implement this in a second. I'm doing this I'm putting in way more effort than I need to. And then an empty packet is a packet list. Probably. And then this has to be a packet list. All right, so my head can be a packet. And okay. So now I know I have a non-empty packet list, not string. Otherwise, I do tail to string. Because not quite. If it's a non-empty, I've made this way harder than it should be, is what's happening here. And I'm almost ready to... I probably should have just approached this in a straightforward fashion. If I'm a non-empty list, I need to do head dot to head, not to string. Because now my head, if I'm an empty packet, it's just head, yeah. So head dot to string plus comma plus tail dot without parens. Oh, my tail is a packet list. This is a packet list. So I have two. So packet, the tail has to be a packet list. So these are just my two options. And yeah. All right, so I think oh God, why did I do this to myself? I have a build error. Non-empty packet list. Oh, hang on. I've lost my example. Oh, the second one is... So I actually had defined this wrong anyway. And this has revealed that. So the first element is a non-empty list like that. And then this is new non empty packet list, new empty packet. And this, I'm gonna rename this empty lists. We're gonna rename this plist pint that's not a compiler error, that's just a failure now. Let's see if we have compiler errors. Goodness. Oh, I needed to add a timeout here too. Timeout. Okay. I am getting closer. Kind of. Can I just do toString on the... Now I'm just guessing. Despair. I'm switching on my tail. If it is a packet list, tail switch, we have two cases. Tail.head. We want to match on tail.head. If the head is a packet, if the head is a packet list, then we need to do it with parens, head.toString plus comma plus tail.toString. Let's check it out. Let's check it out. All right, I'm going to take your example here. Public void third pair. Oh, interesting. Yeah, my connection, unfortunately, this morning, something's not quite right with it. Oh. Fascinating. All right, so let's see if I can build this up. So this should be packet P equals new packet. So this is going to be a packet list where... Oh my goodness. Yeah, so this I got into the trap here where I wanted it to be homogeneous types again. Okay. My brain can't handle non-homogeneous types apparently. The tail can be any packet. All right, we're scrapping it. We're scrapping it. We're going back. I want to solve it this way. I can't get it. All right. We've got P lists. So we either have lists of packets. We're using built-in types. What am I doing here? What is this error? All right, I'm scrapping it. I can't handle it. I should have just stayed with this from the get-go. A P list. Oh, sorry. A P list is one that has Goopta, are you sad that I'm resetting my original one? I'm wrecking my brain here. I just got to, yeah, so the tail has to be a packet. The tail has to be a packet. Goopta's gonna get me to keep going here. Oh. All right, let's go back. So the problem with the definition I have here, the right side can be a packet list, but that's not true. Is it true? This is, oh, my brain hurts. I was trying to make it as simple, and now it's not so simple. I've made it, I thought I was being cool doing Haskell types, but my packet list can be an empty list. So how do I make a list of lists is the question. Oh, because my head can be a packet? Okay, all right, I think you're right. I think I can make it work. All right, so in this case, packet P is a new P list, and the head happens to be a new P int 1, and the tail is a new P list where it's a list. See, this is what I'm saying. I don't think my type defines it properly. My data model is not allowing for me to have this nested list here. Yeah, that's essentially what I had initially, and I've gone down a rabbit hole. My brain keeps wanting to have homogeneous types in my lists, and that's just not going to work. So I guess I don't need to scrap it all. All right, I'm gonna start over here. Oh man, I only got 30 minutes left before I gotta stop. I'm so sad. Oh. Yeah. Well, my type is defined poorly. So I need to be able to represent lists in this way. All right. So my types don't have a good enough, my types don't Yeah, so I was gonna just go back to doing it this way here. Where I can have a list of packets, so that's the one here, and then I can also have a packet int public record p int val, and try not to overthink it. Not overthink. I don't know. I really wanted to do this interesting recursive thing, but the way I was doing it needed homogeneous lists. So this was, if we go back an hour, if we rewind an hour, this is where I was an hour ago. Yeah, so if we rewind, this is where I was an hour ago, and I should have just stuck with it, but I was going, oh, you know what? I'm gonna do this cool thing where I don't use the built-in list type, and I do this crazy recursion all the way down, and that's just not what we want. So now if I have this, it becomes easy to define this. So this one, packet p1 equals, hang on, I'm gonna do public. I'm gonna make my life slightly easier here. What is it? Params int params packet packet and this should be params. How do I do params? C# params. That's what I had at the beginning, and I decided I was crazy. All right, I had it right the first time. Params, and this is just gonna be plist of packets dot to list. Can I not do that? Is not marked. This? There we go. There we go. Yeah. I went a little bit insane. Let's just say I went a little bit insane, so I apologize. Oh yeah, look at that. You're right. Someone had mentioned my stream restarted. It did. It restarted itself at this point 16 minutes ago. So I don't know what's going on with that. That makes me a little bit annoyed. I might have to. I'm not on an Ethernet cable. My router is in another room, but maybe I need to get a 100-foot Ethernet cable and run it so that I'm connected directly to the router. All right, so now this just becomes plist, new plist, new pint1, new pint, or we're gonna do one new int array 1 1 3 1 1 dot select new p int. I was hoping I could do that. And I thought it was gonna be new p int 1, new p int 1, new p int 3, new p int 1, new p int 1, packet p1. I like p0. 1 1 1 5. Assert dot equal 1 1 3 1 1 and p0 dot to string. All right, this should just be much easier. public override string to string return val dot to string. No worries, no worries. You should be able to, if you hit refresh on the stream, I think it catches you up to where I am. Oh, but then you missed what I did. Never mind, never mind. No worries on the suggestions. I think I got it. So this just becomes brackets, plus string dot join, comma, packets. This should be a capital P packet. No worries, no worries. I'm not too worried about it. Yeah, I feel like the 10-second delays feel like they're forever. All right, so now packet p0 equals new plist, new plist, new pint 1. Yeah, I cleared them all out, because I changed my constructor. Comma, new plist, new pint 2, new pint 3, new pint 4. P1, new plist with 1, and then a new pint 4. All right. Oh, Gupta tried to stop me early on, but I wouldn't listen. And here we are, later, trying to do it. back where we were. Back at it. All right, this I don't even need a test for this now because it well, I got one error. P0. Basically don't even need a test because it's so straightforward at this point. Oh, I didn't actually run it. I see what you're saying. I didn't quite understand what you were saying. I understand now, and I'm just bad. I'm not a good programmer. I should just run them all. All right, and this should be 5. If I'd done the parsing earlier, I probably would have stopped right away on it. So I have a data model. I don't have my compare them, but let's go ahead and parse it. And I should have packet. I should have done it from the beginning. String packet. I could just I should have, you know what? I'm looking at this at my brain here. I could probably just parse this in as JSON and then recur on it. That's what I should have done. I should have just used the JSON parser. Oh man. So, all right. I need to parse a packet. And so I am I have... When I encounter a square bracket, so I know when I start out, the very first one I'm doing, let me think through this. I have a square bracket, followed by that. So if I start with a square bracket, I need to remove the outer square brackets to get the inner piece. Maybe I should just use a JSON parser, because man, otherwise I have to do... I need to find the matching parentheses otherwise. A JSON parser might just be the easiest thing to do here. I could do it. I think it's just sort of recursive on how deep I am at what I need to do. I should be able to do it. I can do it. All right, so we'll do a token parser. We'll do char tokens equals packet.toArray. Yeah, so that's about, you know, Gupta, that's where I am. I was just trying to decide whether or not I wanted to do it recursively or iteratively. We're gonna do it iteratively. And we just look for tokens. And we're gonna say int depth equals 0. And then we're gonna say for each char ch in tokens, if ch is a square bracket, depth increases. We sort of have it to like maintain a p list here. Or do I want to... Recursive feels like it might be nice. But then I'm going to be building all these crazy substrings. Yeah. If ch is equal to this, depth minus minus, and if I encounter a number, string current we need to be building up parsing in tokens. I'm gonna change this to chars, and then we're gonna have a string. Is there a string builder? String builder token equals, let's see, C# string builder system.text. New string builder. If char is ch is a comma. Then I can like make my token builder. I'll do something like string token equals token builder.toString, and then token. Then I gotta do something with it. I gotta think that through token builder.clear. So when I see a comma, I consume it. I build this token. Now I have my token. I need to add that sort of to my current list. Else, I know it's going to be an int, so I can actually do int.parse, and then it's going to be a pint, like that. Otherwise, token builder.append ch. Okay, so this is gonna pull out my chunks. Eventually, I'm gonna get my token. I need to do. So this means I need to start constructing a new list, and I'm gonna add things to it. So I know when I see this. My depth +1. These tokens will be in the list at this depth. So when I get here, I need to get all of the when I get here, I need to do a new p list with packets. So I'm going to have a bunch of packets sort of being accumulated. So I know I'm going to need a list of packets. And when I get this token, my idea is that when I encounter this, my list of packets will contain everything that I need. But I might encounter another one here. So I'm going to have packets, not add token. This is sort of like my depth. I need a stack. Of lists of packets, I think. That equals new. Yeah, when I get to a depth, this is where the recursive part made sense to me. I'm gonna push a new plist on there. Surprised I can't do that with this. Oh, it's because it's going to be a list of packets. New list of packets. And when I get to the end, sort of pop it off. But the top here, so when I get this stack.peak.add token, so I'm going to be adding those in. Oh, that's not necessarily true. That I'll have a... Oh, hang on. This is wrong. This is wrong. Because I'm not always going to have an integer on the left or right side. I might be in the middle. Middle of a packet. Yeah. So if we have a case here where our token builder can parse if int dot try parse token builder dot toString. So if we're able to parse it as an int, count int, then we add that in there. New pint, and we need to add that to our token at the top. If it's not, if we've built up can we just ignore it otherwise? Otherwise, we need to pretty close here, I think. I do have to stop, unfortunately. I have a class I need to get to. I'm on the right track, I think. Although I kind of feel like maybe a recursive solution might be a little bit more elegant. All right. Well, I do have to stop here. Unfortunately, I have to start teaching a class. I'm gonna finish this in I don't think I'll stream the finish. Yeah, I think I should do the recursive version, just because it's easier to think about. So basically, if I just need to keep track of the depth. But yeah, I think I'm gonna do a recursive solution here because this is not going exactly. This is harder for me to reason about. All right. Well, as always, thank you for hanging out. It's been lovely. Sorry my connection wasn't the greatest today. I will be back tomorrow morning or evening or whatever time you happen to be there. Have a beautiful day, and you're welcome back anytime.